So this is part 2 of my Find the Rule video, referring to my spreadsheet that I talked about in part 1. And this time we've got a rule. Well, let's see what happens when r equals 1, q equals 11, when r equals 2, q equals 26, when r equals 3, q equals 47, when r equals 4, q equals 74. So it doesn't look like the numbers are going up by a constant amount this time. The first time they go up by 15, the second time they go up by 21, the third time they go up by 27. So they're going up by an increasing amount each time. But having worked out those differences, if we work out the second differences between the differences, we're getting from 15 to 21, 6, from 21 to 27, 6. So I predict that we get 6 again for the next one. So the next difference between the terms should be 33. And then the next term should be 107. Let's just see if that works. When r is 5, q is 107. So there's definitely a pattern there. And when we see these second differences coming out to be constant, that's always a big clue that the rule is going to involve not r, but something like r squared. Now, if the rule were just r squared, then 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, and 5 squared would be 25. The differences between the terms would be from 1 to 4 is 3, from 4 to 9 is 5, from 9 to 16 is 7, and from 16 to 25 is 9, and those are going up by 2 every time. So we'd like something that ends up in those numbers going up by 6 every time, but we're getting numbers that end up with that going up by 2 every time. So that gives us a clue that the rule might have something with 3 times r squared in it. So let's just try 3 times r squared as the rule. So 3 times 1 squared would be 3. 3 times, let's just clear all these. 3 times 2 squared would be 3 times 4, which is 12. 3 times 3 squared would be 27. 3 times 4 squared would be 3 times 16, which is 48. And 3 times 5 squared would be 3 times 25, which is 75. So that does indeed give us numbers where they go up by an increasing amount every time. 9, 15, and 21, and 27. And those increases go up by 6 every time. So the rule's definitely got a 3r squared in it somewhere, but that's still not the sequence we're looking for, because we're trying to, let's just delete the irrelevant stuff. We're trying to achieve a sequence that says 11, 26, 47, 74, and 107, but we've only achieved a sequence that goes 3, 12, 27, 48, 75. Well, let's have a look now at the difference between the sequence we're trying to achieve and the sequence we're getting. So we're getting, from the rule 3r squared, we're getting 3 for the first one. We want it to be 11, so there's a difference of 8. We want the next one to be 26, but we're only getting 12, so there's a difference of 14. And we want the next one to be 47, but we're only getting 27, so there's a difference of 20. Now I'm starting to notice a pattern here, that the difference between what we're trying to achieve and what we're getting is going up by 6 every time. So if we can get a pattern for these numbers that we need to add on, then we're almost there. Well, if these are going up by 6 every time the r's go up by 1, then it could have something to do with 6n, 6r I should say. So if the rule were 3r squared plus 6r, let's just make that a little bit wider and get rid of that. Get rid of that. Okay, so instead of 3, we'd have 3 plus 6 times 1, which would be 9. Instead of 12, we'd have 12 plus 6 times 2, which would be 24. Instead of 27, we'd have 27 plus 6 times 3, which would be 45. Instead of 48, we'd have 48 plus 6 times 4, which is 48 plus 24, which is 72. And instead of 75, we'd have 75 plus 6 times 5, which makes 105. That's still not the numbers we want, but we're very close now because we can see that we just need to add 2 to any of these numbers and we get the sequence we're trying to achieve. So the rule is in fact 3r squared plus 6r plus 2. Q equals, well, I can write it up there, 3r squared plus 6r plus 2. And then it would be 11 and 26 and 47 and 74 and 107. Now, I should test that. So let's say if x was 6, what would we get? So if x was 6, we'd get, that would be 3 times 6 times 6 plus 6 times 6 plus 2. So we're predicting the next one should be 146. Let's see if that works out. When r equals 6, I think I said x before, r and q they're called, we do indeed get 146. So that works. And as before, the rule is down there and you can change it if you like and try and get somebody else to guess your rule. Okay, so that's that, and we will move on to level 5. So let's have a look at level 5. When t equals 1, m equals 18. When t equals 2, m equals 36. When t equals 3, m equals 72. And I'm noticing here that they're doubling every time. So this one here is 18. This one here is 18 times 2. This one here is 18 times 2 squared. And so on and so on. So that's a pattern that I can start to generalize. So it always seems to be 18 times 2 to the power of something. So I'm expecting the next one would be 18 times 2 to the power of 3 when t is 4. I would expect the ninth one to be 18 times 2 to the power of 8. And then always 18 times 2 to the power of 1 less than the t there. So one way of writing the rule could be m equals 18 times 2 to the power of n minus 1. Of course, 18, 2 goes into 18, so another way I can think of this is of the first one being 9 times 2. The second one being 9 times 2 times, let me just write the numbers there. So it was 18, 36, 72, just to remind ourselves. So I can think of the first one as being 9 times 2. I can think of the second one as being 9 times 2 squared. 9 times 2 times 2. I can think of the third one as being times another 2 again. So 9 times 2 times 2 times 2, or 9 times 2 cubed. So that generally speaking, another way of writing the rule is a slightly simpler 9 times 2 to the power of n. Okay, level 6, similar kind of thing. Let's see what happens. So when u is 1, r equals 7. Okay, when u is 2, r is 14. Okay, when u is 3, r is 28. So they're doubling every time again. So generally, the first one's 7, the second one's 7 times 2, the third one's times another 2, so 7 times 2 times another 2, and generally speaking they're always 7 times 2 to the power of, well, it's always 1 less than the original u number. So the rule is 7 times 2 to the power of u minus 1. And again, you can go down, change the rule for some different numbers, and maybe a different number for both of those. 5 times 3 to the u minus 1. Same thing with the level 5, 1. You can go down, change the rule for something else, and try and get somebody else to guess your rule using the same thought process that I just went through.